Today, we are going to explore a concept that is changing the way modern software is built. It may sound technical at first, but we'll break it down into something simple and easy to understand by connecting it to a real-world experience that most of us can relate to: microservices. Now, right off the bat, even the word itself usually sounds incredibly complicated, doesn't it? You hear terms like APIs, service meshes, gateways, and containers, and suddenly your brain just kind of shuts down. It honestly sounds like this tangled web of technical jargon that's just designed to keep consultants in business. But what if I told you that you actually already understand them? Seriously, if you have ever navigated a modern international airport, you have intuitively lived and breathed this exact complex software architecture without even realizing it. I want you to imagine how people booked international travel back in the day. You walked into one single travel agency where every single service is handled under one roof: flight bookings, hotels, car rentals, visas, airport transfers. But behind the desk, they all share one giant filing cabinet. That is your single traditional database. When one agent locks a file for a strict database transaction, everybody else just has to stand there and wait. Now it works totally fine initially, but as demand grows, they start stepping on each other's toes and the line quickly stretches right out the door. And this perfectly illustrates the fatal flaw of what we call the monolith. Think about it. A single bug in the visa department crashes the entire agency because everything shares the exact same code base in that one database. Nobody can book flights. Nobody can rent cars. The whole operation just stops. Plus, scaling this is financially inefficient. If visa applications suddenly spike, you can't just scale up that one desk. You literally have to replicate the entire agency. It is a highly fragile and costly system to run. Step into a modern international airport. The very moment you step inside a modern terminal, you immediately notice something profound. Nobody does everything: check-in, baggage handling, security screening, boarding gates, customs. Every single one is completely specialized with its own staff and completely isolated systems. And because they are specialized, the security team can update their protocols without having to ask the baggage team for permission. This decoupling is a massive deal because it completely accelerates how fast a business can move. So instead of one giant application, you break your software down into independent services where each one acts like an isolated data vault. Your payment service handles transactions in its own database while inventory tracks stock in another. Now, here's the question. If all these departments are completely separate, how does a traveler actually navigate the airport? You walk in through one set of doors, there's a large information desk right there, and above it, signs directing you everywhere you need to go. You don't need to know where the baggage sorting room is. You don't need to know which specific security lane to use. You just walk up to the information desk, tell them where you're going, and they point you in exactly the right direction. Now apply that to software. In a microservices system, your users and client apps, whether that's a mobile app or website or another system, they have one address, one entry point. They do not talk directly to the payment service. They do not call the user service directly. They do not know or need to know where any of those individual services live. They just talk to the API gateway. The gateway is the information desk. It receives every single incoming request and figures out exactly where to send it. User trying to log in, gateway routes that to the authentication service. User placing an order, gateway routes that to the order service, which then talks to the payment service and the inventory service behind the scenes. And the gateway does more than just routing. Think about what happens when you walk into an airport. Before you go anywhere, you show your boarding pass. You prove you're supposed to be there. The API gateway does the same thing. It handles authentication and authorization before a single request reaches any internal service. It also handles rate limiting. Think of it as airport security controlling how many people flow through per minute. It can handle logging, analytics, SSL termination, all in one place, one door in one place that knows where everything is. Every request goes through it. That's your API gateway. But here's a new problem. The airport information desk is great, but how does it know where to send you? How does it know that check-in is in Terminal A or that Gate C14 is operational today and not under renovation? Somebody has to maintain that list and that list has to stay current. That's service discovery. Look up at those giant departure boards in any major airport. They're constantly updating. Flights are assigned to gates. Gates change. New flights appear. Cancel flights disappear. And critically, every department that needs that information has access to it in real time. The ground crew knows which gate to direct the plane to. The baggage team knows which belt to load your luggage onto. The boarding staff knows their gate assignment. Nobody had to call each other on the phone and manually update a spreadsheet. There's a central live board. Everyone registers to it. Everyone reads from it. That is service discovery. In a microservices system, services are constantly coming and going. When you deploy a new instance of your payment service, it needs to register itself to say, hey, I'm here, I'm healthy, here's my address. When an instance shuts down, it deregisters. This happens through a service registry. Think of it as the airport's live flight database that powers those departure boards. Now, when your order service needs to talk to your payment service, it doesn't use a hard-coded address that might be outdated in 5 minutes. It queries the registry, it checks the departure board and gets the current live address of a healthy payment service instance. This is huge in microservices because unlike the old travel agency where everything lived in one building, your services might be running across dozens or hundreds of servers, all spinning up and shutting down dynamically. Service discovery is what keeps them all from losing track of each other. Now if you head to the check-in area for a popular airline on a really busy morning, you're not going to see just one counter. You will see 10 or 20 counters all handling the exact same flight. In our software architecture, this is load balancing. We don't just run one single instance of a critical service. We run multiple copies simultaneously. A load balancer acts just like the coordinator at the front of the line, distributing all that incoming traffic evenly. If one counter crashes or runs out of bag tags, the coordinator seamlessly redirects the very next passenger to an open counter without any disruption to the user whatsoever. And this perfectly proves the incredible business value of this setup. Let's say it's a quiet Tuesday. Low demand means you only run a few instances, keeping your operational costs super low. But during a massive holiday rush, you can dynamically spin up more instances and the load balancer immediately includes them in the rotation. You're only paying for the computing power you actually use, achieving true financial efficiency and resilience. Let's land this plane. You started with the travel agency, the monolith, one system, one team. Everything coupled together works fine when small, becomes a fragile, unscalable mess when it grows. Then you walked into the airport, the microservices application. Every department is a separate independent service. Check-in, baggage, security, boarding. Each one specialized, each one isolated, each one deployable on its own. The main entrance and information desk is your API gateway. Every request from every user and every system flows through this single entry point. It handles routing, authentication, rate limiting. So your internal services don't have to worry about any of that. The departure boards are service discovery. Services register themselves, announce their location, and find each other dynamically. No hard-coded addresses, no stale configuration, a live real-time registry, and the multiple check-in counters are load balancing. Traffic distributed across many healthy instances. If one goes down, the others absorb the load. Scale up when demand rises. Scale down when it drops. Okay? Look at what we've built here. We have transformed a fragile monolith into a beautifully organized airport. We broke everything into independent data walls to completely decouple our deployment schedules. We put an API gateway at the front to act as our information desk. We implemented service discovery as our live departure board so our services can find each other dynamically. And we added load balancing as our check-in counters to easily manage massive traffic spikes. Together, these patterns coordinate perfectly to yield immense financial return and incredible market agility. As we wrap up, I want to leave you with a rather stark business reality to consider. Your old monolithic travel agency might still be doing the job right now, but the question isn't whether it works today. The real question is, when traffic triples next quarter, which architecture do you want to be running? If you found this helpful, don't forget to like, subscribe, and drop a comment if you have any questions. Thanks for watching and see you in the next video.